Hi everyone, and welcome to our talk. We'll be presenting OkwuGbe, end-to-end deep speech recognition for Igbo and for fun. I, Bernard Bonamochodo, so will be presenting this for with my colleague, Chris Emezuye.
Hello, everyone. I'm so glad to be here and we're so happy to be presenting our study with you. Okwube is got from the concatenation of two words, Oku in Igbo, that's my language, and Be in Bon's language. I hope I'm saying it well, Be. And basically, the idea
Igbe.
is Okwu means speech and Bear means languages. And when you bring it together, is speech of languages. The inspiration behind this is to promote research into exploring the speech of African languages. So, speech processing of African languages. That's basically it.
Yeah, and also unify them.
And unify them, yeah.
Yeah, so one very great and motivational quote that we found going along with our idea, motivation, research, and everything is this beautiful quote from Nelson Mandela, who said that if you speak to people, a group of person in a language that they understand, then you sure that what you're saying, what you're telling them goes straight to their head. But then when you use or when you talk to them in their own native language, it goes directly to their hearts. So nice, Chris, we go on with the problem challenges what we're having, the step we took to overcome them.
Yeah, that's a very wonderful quote. Unfortunately, there isn't much opportunity to speak to people in or people speaking in African languages because when you look at the trend from African languages and non-African languages, we see that there is generally very little research or projects being done in automatic speech recognition specifically for African languages. We face this issue when we're working on Fon and Igbo.
Yeah,
This has a lot of consequences in the future because they, first of all, these languages could become extinct and there won't be a fair use of AI technologies in these languages. And these these problems and trying to solve these problems and challenges is what inspired and promoted our research.
yeah. So in our paper, we try to produce and to also provide, let me say, a very comprehensive and very detailed linguistic background of both languages. I mean, we are not linguistic students, we are not linguistics, but we try to go down to the roots to understand how the language is spoken and everything. And on the technical part, we also give very specific detail about the model architecture and the line, like for instance, the end-to-end deep neural network that we have used in our work and have recently in the recent years they've been very useful and efficient in the automatic speech recognition class. The outcome of this is we present two models. The front model, which is achieving a state of art on the task of ASR, and the Igbo model that is definitely, we think, a benchmark that could help to uh, to have much more experience and result on the field.
Yeah, that's true.
Yeah,
So when we come to the linguistic analysis, we try to first of all give an in-depth analysis of Fon and Igbo languages because we feel this is very important to understanding the language. And when you understand the language, then you can know how best to build your ASR model. So our paper has an
yeah,
in-depth analysis of both languages, and this table is to summarize our findings. There are some similarities and some differences. For example, some similarities. They are both tonal. They both have many dialects, so one language but many dialects, and this affects the speech environment of this language. Some
yeah,
differences, we see that interestingly in Igbo there is this feature code switching where Igbo natives and bilinguals mix Igbo sentences with a bit of English. And we also try to look into this very well and understand the different forms of code switching because they affect the ASR for this language.
Yeah. So to build the models that we are going to present to introduce, we look for data. In my case, for the phone corpora, we have already a data set that was already available from a previous work from Dr. Laleye. It composes mainly 10 hours or 10 hours, sorry, of speech and basically 1,500 sentences. We reference the website from which the sentences have been taken and also the link to which at which sorry the code or the data set could be easily accessed for further research.
For the Igbo and copper, we searched around, and unfortunately, we discovered that there isn't really any open source Igbo speech dataset. And this led us to start working on one. So currently, we're working on an open source Igbo dataset, and but that's for another research. The one we finally used for this research, research was from the a licensed one from Linguistic Data Consortium. This licensed one is not open source, and also this licensed one had all the diacritics stripped off, which wasn't really fair for our research, which was more into looking at the effects of diacritics on ASR for African languages. We also had to
Yeah.
undergo thorough filtering and cleaning of this data set as Igbo natives, removing the background noises and listening to the audio data set, audio samples to remove the faulty ones and that. For the pre-processing, we underwent speech pre-processing and text pre-processing. For the speech pre-processing, that's using the sampling rate, fast Fourier transformation, and converting into Mel spectrograms using the narrowband. For the text pre-processing, the key feature of our research is that we are working with diacritics, and because a lot of research in African languages have shown that adding leaving the diacritics of the language helps to give more information about the sound, how to pronounce this word, or what does this word mean, unlike removing the diacritics. So we keep the diacritics and we wrote special functions to allow the program understand these diacritics because most programs split the diacritics and the letter, but we had to keep them together and help the model learn with the diacritics.
Yeah. So our model or the different models we try are mainly based on made of sorry three components: the res component, the bidirectional RSTM and GIUs, and the so-called Badano attention mechanism. So we tried four different kind of models, like you can see. We tried to see how how with the combination of RCNN with BiGIU we work along with RSTM along work or with BiLSTM and BiGIU in the system of encoder decoder will work, and also maybe a little bit cheating of the context machine translation we try now to also insert into that scheme of encoder decoder the Badano attention mechanism.
Yeah. So as Bona said, we tried different model stacks, and for each model stack, we also tried different number of layers. So
Yeah.
the best model is shown here in this picture, and we try to design it to explain a lot of things. And it's basically made up of three blocks: the residual convolution neural network block, the bi-LSTM block and the bi-GRE block. The convolution neural network block basically takes this Mel spectrogram as images and tries to learn the abstract features of this spectrogram and passes these features into the recurrent neural network blocks, which now uses it in a time step way to decode the transcript at the end. So the best model was got from 5 layers of RCNN block, 3 layers of BiLSTM, and 3 layers of BiGRU. Furthermore, each layer of RCNN, it's basically using the residual element where you add the previous the output from previous layer into the after doing two levels of convolution as shown on the orange side. On the blue side, we also try to illustrate a little bit how we added the attention mechanism to the model's predictions, as you can see here,
Yeah,
with the bidirectional and the attention stuff.
exactly. So we wrote much more detailed explanation about the different tricks, problem we encountered implementing the attention and everything in our paper that we invite you to read. So I will go further about the results. And this table shows mainly that the attention mechanisms really help improving the word error rate, which is, I would say, the kind of metric or the kind of parameter, whatever we can call it, that help to judge, to leverage the performance of a speech recognition model. So we can see for both language, Igbo and Fon, that the best word error rate has been achieved with the attention mechanism. Yeah, and also for Fon, our bus model have outperformed the current and unique ASR model built for phone by Dr. Lai in 2016. Here we can see some predictions and some targets actually from the base phone ASR model. We can just notice very two kind of things. Basically, just the substitution, right? Like for instance, in the third sentence, Gosin, we're expecting Gosin to get, Gosin as two separate words, but then the model inserts in those words, remove, sorry, the both the blank space, the character space. If we go to the second sentence, we were expecting Akpon like AKPAN, but then the model inserted let me say, another character A. So doing that trick of substitution, insertion, and deletion is mainly, we think, what is very affecting the word error rate. Otherwise, as foreign native speaker and as also other people that are included in this study, those errors are not really noticeable in the speaking. So this is something definitely that we are looking forward to make sure that we have a better model that is able actually to capture those one in, to know when to insert, when to delete, and then when to make substitution.
Thank you very much, Bona. I also want to add that for the Igbo, since there is no, to the best of our knowledge, we didn't find any pre-existing Igbo ASR model. So this serves as the benchmark or the first for Igbo. And of course, it's hoped we're working on improving this model for Igbo and Fon, and we will get better results. And in the future, there'll be better results. Another important analysis we observed is that there is a for fun, there is a large gap between the word error rate and the character error rate. The word error rate, as Bona explained, it's like it's comparing the prediction and the target on a word level, and the character error
Yeah,
rate is comparing on a character level. So for fun, there's a large gap, whereas for Igbo, the gap is not that noticeable. We try to understand why this might happen, and one reason we have is the character set of Fon and Igbo. So if you remember back, we said that for Fon, we included the diacritics. So it means for each letter that has a diacritic, we included all the possible diacritics. So for A, you have like A ascentego, asongraph, ason circumflex. You have all the macron. You have all the possible diacritics of this letter. Whereas for Igbo,
yeah,
because of the data set, there were no diacritics. So we believe that since the character set for Fawn is way larger than that of Igbo, at the rate we trained, the model still had some issues. As we can see in the next slide, the model still had some issues, like Bonner explained, inserting or not inserting. For example, here we have on the target we have the E, and on the prediction it's the E with the accent. So it's not noticeable, but on the text level you can see the difference. For the other example, you can see the ghosting, as Bonner said, where it's not adding the blank character in between. We believe
yeah,
that with with more improved training mechanisms. Like there's headroom to explore in the model architectures and headroom to explore in the hyperparameters. And with more of this, we will be able to improve the state of these models. It's also important to note
Yeah.
that all this research we did were with very low computational resources. We had to do a lot of things, I would say, to accommodate this. For example, for the attention mechanism, Bonaventure had to like create this system where the attention weights are not being saved into the GPU memory. If not, this wouldn't work. We also had to experiment with gradient accumulation with very low batch, which didn't really work so well for ASR, but we had to try that. And thanks to Professor Graham Newbeck, who gave us an Amazon EC2 instance, which helped a little bit. But so we had to do all this research with low computational resources, and we believe that with better computational resources, like the type being done at other companies, we will be able to attain better results and very interesting analysis for these languages.
Yeah. I completely agree with Chris. And yeah, so that's it. For me, we say enochenome to say thank you. Okay, to express gratitude because there's not really such word as thank you in front. So how do you say it in your language,
In
Chris?
Igbo, we say dalo or emailer or something like that. It's also, like you said, to express
Oh,
gratitude. So thank you very
okay.
much for your
So
attention. Dalo and
Dalu.
Anchenomi.